Functions. A function is a special kind of relation in which each input has only one output. So remember, an input is an x value and an output is a y value. So a function is simply a special kind of relation in which each x value has only one y value. Now let's talk about how to identify a function. In the next few slides, we'll look at each of the four representations of a relation, and we'll discuss how to tell whether or not that relation is a function. Let's begin with ordered pairs. When you see a set of ordered pairs, you need to ask yourself, do the x values repeat? So looking at example 1, we need to focus our attention on the x values. 2, 5, -3, and -2. Do these x values repeat? Well, the answer to that question is no. None of these x values repeat. So what that means that this is a function. Now, not only will you have to tell me whether or not it's a function, you should also be able to tell me why it's a function. So this is a function because each input has only one output. When we look at this list of ordered pairs, the number 2 has only one output, which is the number 4. The number 5 has only one output, which is the number 3. The number -3 has only one output, which is the number 7. And -2 has only one output, 9. Example 2. Again, let's ask ourselves, do the x values repeat? So we'll take a look at 1, -4, 1, and 2. So the answer to this question is yes. Does everyone see that the number 1 repeats twice? So this means that this is not a function. And the reason this is not a function is because the input 1 has more than one output. So what are the outputs that the number 1 has? Well, the number 1 has the output 2, and it also has the output 5. It does not have just one output, it has 2. Let's move on to looking at a table. Now, a table is very similar to a set of ordered pairs. So again, you ask yourself, do the x values repeat? Looking at this table, we're going to look at our x values, which are listed here, 1, 2, 3, and 4. Do these x values repeat? No. So this is a function because each input has only one output. Example 4. Again, we're going to look at our x values. And our x values are 1, 2, 1, and 3. Now, when I look here, I see the number 1 twice. Okay? So do the x values repeat? Yes, the x values do repeat. So this is not a function. This is not a function because the input 1 has more than one output. And those outputs are 2 and 5. All right, now looking at a graph. And for a graph, the question that you ask yourself is, does a vertical line drawn through the graph cross the graph more than once? Now remember, a vertical line is up and down, so this will be considered a vertical line. Do not confuse that with a horizontal line, which goes left to right. Okay, do not confuse those. When we talk about vertical line, we're talking about up and down. So let's take a look at example 5. So if we draw a vertical line through this graph, and by graph, we do not mean the coordinate plane. What we mean by graph is the actual line drawn within the coordinate plane. So this is considered the graph. So if we draw a vertical line through that graph, we want to take note of how many times that line crosses the graph. So this line actually only crosses the graph right here. It crosses one time. So to answer our question, does a vertical line drawn through the graph cross the graph more than once? Our answer is no. So what that means that this is a function. And again, it's a function because you can either say it passes the vertical line test, or you can continue to say what we've been saying, which is because each input has only one output. Example 6. Now let's try this one. When we draw a vertical line through this graph, we can see that this line crosses this graph once here, and it also crosses this graph once here. So to answer our question, we would say yes, this line does cross this graph more than once. So this is not a function. And this is not a function because we're not going to say each here. Actually, what we can say here is that because it does not pass the vertical line test. Okay. Now we could be more specific. If it weren't as blurry, we could take note of what the actual X value was. And we could say, you know, just like we did before, that at, I don't know what this number is, but the number 11, at the X value 11, it had more than one output. But we can't really tell on this graph. So just saying that it does not pass a vertical line test is sufficient. So lastly, let's look at a mapping diagram. With a mapping diagram, you need to ask yourself, do any of the X values have more than one line drawn from it? So the place that we should be looking is right here. We want to look at our X values. We want to take a look at the lines that are drawn from the X values. So do any of these X values have more than one line drawn from it? Our answer is no. So therefore it is a function because each input has only one output. Example 8, we're going to ask ourselves the same question, looking at these X values. Do any of these X values have more than one line drawn from it? Well, I can see right here at the number 4, we have how many lines? 1, 2, 3 lines drawn from it. So what that is telling us is that the input 4 has 3 different outputs. So yes, it has more than one line drawn from it. So therefore, this is not a function. And it's not a function because the input 4 has more than one output. And those outputs are 0, 2, and 3.